All right, this is Mr. Gillum, and today we're going to continue dividing a whole number by a fraction. And this is lesson 7, day 2 in your instruction book on page 60. It says that Kelly drank 2/5 of the water in her bottle. She drank 3 cups of water. How many total cups of water were in her bottle? And so when we think about this problem, there's a few things I want to think about. She drank 2/5 of the water, and that was a total of 3 cups. We need to know how much was in the bottle to start with. So let's picture this, and I'm going to show you kind of how to draw a picture from scratch. I know there's one already in your book, which is fine, but I'm going to picture the bottle here, and I'm going to divide the bottle into fifths because I know that 2/5 of the water is gone. This is how much she drank. Gone. Or drank. She drank it up, okay? This represents water left. Okay, and I'm even going to put a little squiggle line in there to represent. That's how much water is left in her bottle. So it says that, goes on to tell us that 3 cups of water is how much she drank. Okay, so I know that 3 cups are gone. Okay, and it says how many total cups were in her bottle. So I need to know, so 3 cups was 2/5. I need to know how many cups the entire thing was. So I need to know how much the entire bottle was. And so it says the bar represents Kelly's water bottle. You can divide the bar into fifths and shade 2/5 to represent the amount of water Kelly drank, 3 cups. Okay, so I guess the model that is drawn in your book must have 2 shaded parts representing the parts that she has drank. So mine's a little bit different than the one in your book, and that's the one we're going to use. So, but I hope that this model makes sense and how I constructed it makes sense. So let's move on here to the modeling. It says that we could also use words and equations to understand the problem. We know that 2/5 of the total amount of water equals 3. So before, what we were doing with expressions, we were saying like, oh, I need to know what 13% of 100 is, something along those lines. And so I knew that the percent means per 100, the word of means multiply, and then I would multiply that by the number, and I would figure out what 13% of 300 was through multiplication. This is very similar, except for the part that we don't know is in a different place in our equation. In this case, the unknown is the second value. So we know that 2/5 of the total amount of water equals 3 cups. So in order to do this, we actually need to figure out how many 2/5 go into 3. We need to figure out a number times 2/5 that equals 3. And because because multiplication and division are inverse operations, I know that if I divide 3 by 2/5, I can figure out what times 2/5 actually equals 3. That's how multiplication, division, that's their relationship. So in this case, I would think of my expression like this. Actually, this would be an equation like this. But when I'm trying to figure out what times 2/5 equals 3, I need to know how many times 2/5 goes into 3 to know what to multiply it by. So I would divide by 2/5. So I would change my equation to 3 divided by 2/5 to find the total amount of water. Hopefully that becomes clear as we work through this problem. It says, okay, so you can see that this is the model in your book. And you can see that in their model, they labeled how much she has drank. So this is how much she has drank. And this is how much she has not drank. And we need to know how much the total, how many total cups are in a water bottle. So it says, why did they divide the bar into fifths? Well, that's a great question. The reason they divided the bottle into fifths is because that 2/5 of the water is gone. And so if I divide it into fifths, I can cross out 2 of them, representing that that's how much that she's already drank. So it says the problem says that Kelly drank 2/5 of the bottle, so you need to show fifths and mark 2 of them, representing how much she's already drank. It says, how can you use picture it to find out how many cups of water were in the bottle? Okay, so this is a good example of how to use your model. So you can see that they labeled on your model 1.5 on each of these fifths. So the reason they did that was because they know that 3 cups represents how much she drank, and she drank 2/5 of the water. So obviously 1/5 is half of 2/5. So half of 3 cups would be 1.5 cups. If each fifth was 1.5 cups, it would make sense that 2/5 would be 3 cups, because half of 3 is 1.5. So if each fifth piece is 1.5 cups, I could add up 1 1/2 plus 1 1/2 plus another one, plus 1 1/2 plus 1 1/2 plus 1 1/2 to figure out how many cups the bottle actually holds altogether. And so there's a lot of different questions we can answer with this. We could ask, well, how much more does she need to drink to finish off her bottle? Well, it'd be this much. But it doesn't say that. It says how many total cups of water were there to start with. So it would be the amount that she has not drank yet and the amount that she has drank all together. So when I do this, I'm going to I know that 1.5 and 1.5 is 3. That's where we started with. So that means there's 3 more here, and there's 1.5 more here. So 3 plus 3 plus 1.5, or 3 plus 3 plus 1.5. That equals 7.5. So that's one way that we could do it. We could also do it like this. We could say, oh, well, there's 5 1/5 in a whole, and each 1/5 is 1 1/2, so we could take 5 times 1 1/2. So to do that, we would probably need to change it to a mixed number, an improper fraction. 2 times 1 plus 1 is 3/2, and then multiply straight across, which is 15/2, otherwise known as 7 1/2. 2 goes into 15 7 times with 1 extra, so 7 1/2. So either of those ways would be fine. It looks like the book says that since 3 cups is 2/5, you know that 1/5 is 1 1/2 cups. That's this information here. Each 1/5 is 1 1/2 cups. You can multiply that by 5 to find the total number of cups of water that were in the bottle. Multiplying by 5 and adding 1 1/2 5 times are the same exact thing. So either way would be fine to do that. Just need to be careful with your explanation. It says, how many total cups of water were in Kelly's bottle? So we decided just now that it was 7 1/2. 5 times 1/2 equals 7.5 cups. Sorry, I should have put that on the same slide. We decided on 7.5. We decided 7.5 when we added. If we added it this way, 7 1/2. There are 7 1/2 cups to start before anything was drank out of the bottle. In the modeling problem, it's a little trickier, something we're going to learn about more when we do equations, but it's important to understand this. It's important to understand that I know that 3 times 2 equals 6, so I know that 6 divided by 2 equals 3, or 6 divided by 3 equals 2. And so here's the relationship. If I didn't know what the 3 was, I could take 6 divided by 3 to get the 2. If I didn't know what the 3 was, I could take 6 divided by 2 to equal 3. And so that is the relationship that we're talking about when we're looking at this equation. Because a lot of times with fractions, it's hard to do mental math knowing what times something else equals another number if it's all fractions. So this is the relationship we're using. So if I didn't know 3 times something equals 6, I could divide 6 divided by 3 to figure out what that would be. In this case, 2. Okay, so I hope that makes sense. I hope that relationship makes sense, the inverse relationship there between multiplication and division. So it says look at the model it on the previous page and find what 3 divided by 2/5 actually is. So in this case, instead of being 3 times something equals 6, it is 2/5 times something equals 3. And so the same way we think about this, we think about the equation here with fractions. So I need to figure out actually what is, this would turn into 6 divided by 3 equals something, and this, in this case, we would say 3 divided by 2/5 equals something. So when I figure out what 3 divided by 2/5 is, I can do a lot of things. I can draw a double number line to figure out this, but I'm going to go ahead and use the keep, change, flip method because I think it's the most efficient way for now. I'm going to keep the 3, change the division to multiplication, and flip the second fraction. 15 halves. So in this case, 15 divided by 2 would be 7.5. Or you can think about how many times 2 goes into 15, which is 7. 1 left over, 7 1/2. So 3 divided by 2 fifths is the same as 3 multiplied by 5 halves, which equals 15 halves, or 7 1/2 cups. Explain how to use multiplication to divide a whole number by a fraction. It says that dividing by a fraction is the same as multiplying by its inverse. So basically it's explaining the keep, change, flip method. It says multiply the whole number by the reciprocal of the fraction. So you keep the first one, you change the division to multiply, and you find the reciprocal, fancy word for flipping over the second fraction. Okay. It says how many 1 1/2 servings are there in 12 cups of juice? Okay, so if I had, so this is a separate problem, separate, whole different thing. We're not talking about the fifths model anymore. We're talking about how many 1 1/2 cup servings are there in 12 cups of juice. So what I need to figure out is how many 1 1/2s fit into 12. Now, when I think about this problem, I know, because I deal with money a lot, that 1 1/2 twice is $3, and that's an easy number to add together rather than adding 1 1/2 together. So I know that 2 1 1/2 cups would be 3. 1 1/2 plus 1 1/2. That equals 3, and I know that we can do 3 plus 3 plus 3 plus 3 to equal 12. So I would know that 2, 4, 6, 8, there would be 8 1 1/2 cup servings and 12 cups of juice. That's how I would figure it out initially. Or I could think, okay, well, I need to know how many 1 1/2s are in 12, so I could divide 12 by 1 1/2. So hopefully everybody knows how to change a mixed number into an improper fraction. 1 1/2 is modeled like this. 1 whole and 1/2 of a whole. So you can see that actually 1, 2, 3 halves is the same as 1 1/2. So 12 divided by 3 halves. The quicker way to do that would be, say, 2 times 1 plus 1 equals 3 over 2. Okay, you keep the denominator the same. I hope that everybody knows that. Okay, 12 divided by 3 halves would be the same as keep, change, flip. 12 multiplied by 2/3. And then I can multiply straight across, or I can cross reduce if I notice that. 24 thirds, and I know 24 is divisible by 3. 3 goes into 3 once, into 24 8 times. So 8 would be my solution. I get the same answer using the keep, change, flip method as I did using the addition method that I showed earlier. Finally, it says that it takes Emily 9 minutes to bicycle 3/10 of the way to school. How many minutes does it take Emily to bicycle all the way to school? Okay, so let's just pretend Emily's on her path with her bike. And she's going to school. And here's her path. And let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that this is separated into 10 pieces. Each of these pieces is 1/10. So she has gone 1, 2, 3 of the tenths, 4, 5, 6, 7, 8, 9, 10. 3 of the tenths of the way there. This is how far she's traveled. This is how far she needs to go. How far she needs to go is represented by the last 7/10. It says it takes her 9 minutes to bicycle 3/10 of the way there. So I know that the 9 can go here. So I could figure out a unit rate for this problem, or I could use equivalent fractions. We need to know how many minutes it takes her to get all the way to school. So that is what I'm going to do in this case. I see that 3 is to 9, like 1 is to 3. Or I can think about the comparison 9 to 3 and divide by 3, which is 3 to 1. So 3 to 1. So I know that if it takes her 3 minutes to go 1/10 of the way to school, and I multiply 1 times 10, 10/10 or 100% of the way there, if I multiply that, it must be a 30-minute drive to school. Okay, so that's how I would do that. I would model that problem. And it must be a 30-minute drive to school times 10. Okay, that's it for today.